Hey there, welcome back to another video. Today we're going to tear down and inspect an early first generation 480E. This is out of a 1994 C2500 series truck, two-wheel drive, and the story with this is that all of the upshifts were extremely harsh, extremely rough. That's really the only drivability symptom that was reported to me. So the 1-2 shift is backbraking, or said to be backbraking. The 2-3 shift is extremely harsh, and the 3-4 shift, although harsh, is not as bad as the other two. All the downshifts are fine, and reverse works. So customer also advised that a B&M shift kit has been installed. So that by itself is sufficient to explain why these shifts are so harsh. If you guys know anything about B&M kits, they're really geared toward racing and really meant to be used with high stall applications. So if you're running a B&M shift kit and you're installing it into what is otherwise a largely stock vehicle, stock engine with a stock stall converter, and you follow their instructions to the T when it comes to the feed hole sizes for each of the gear transitions, then you're going to have really, really rough shifts more than, more likely than not. So, the other things that we're going to look at are, and this especially applies to the 1-2 transition, is we're going to pay close attention to the feed hole sizes, especially the 1-2 feed hole size. We're also going to look at the 1-2 accumulator piston and spring to see if it's broken. Now, admittedly, I've never, at least me personally, never seen one broken, but there's always a time for firsts. I'm also going to look at the valve body to see if there's anything unusual done with the 1-2 accumulator regulator valve, the valve on the spring, if something different was done there. And then before we take the intermediate clutch out of the case, I'm going to just assess visually the amount of clearance it has. So I don't know if this has been gone through. I don't think it has. I believe other than the installation of the shift kit, the transmission is original. So I shouldn't expect to find any kind of mods or things done that would indicate that it has been rebuilt, but I could be wrong. So we'll see. Alright, quick background on the 480Es in general, and I go over the same stuff in the 480E teardown inspection of the later model unit, but I recognize two generations of 480E, first generation and second generation. And first generation is defined as all production years starting in 1991 through 1996, that's your first generation, and then second generation is going to be all years of production to 1997 through 2013, which I believe is the last year for these. So 480Es were installed in all manner of heavy-duty 3/4 and 1-ton applications, for your trucks, your SUVs, your vans, and then they were also installed into some Corvettes and possibly Camaros, but don't quote me on that. And to be honest with you, what vehicles they were in and not in is not critically important for the purposes of this video. Here we want to draw comparisons and contrast the different individual parts and groups of parts that all work together, aka service packs, that are different in the 1991 through 96 units and the 1997 and up units. Now, within the span of first generation, that 91 to 96 time frame, there are three vintages that I recognize: 1991 through 1993, 1994, which is a standalone year, which is what we have here, and then 1995 and 96. And there were what I will call material changes to different parts inside the transmission that make them distinguishable between each vintage. And some things can be interchanged, but some cannot, at least not without some modification. So we'll go over those things as we move through the teardown. Now, I'll tell you straight away, the gear train in the rear, which is your center support to your output shaft, in 1991 through 96, that entire gear train, none of it is interchangeable with anything 1997 and up, okay? Because 1997 and up is when they completely redesigned and re-engineered the lubrication circuitry for that gear train, transitioning to what is referred to as a center lube design. So your two cooler line fittings, which you see here on the case, the return line fitting was moved from its position right behind the bell housing, relocated toward the rear of the case to pipe freshly cooled return oil directly into the center support to lubricate the gear train first. It wasn't routed through the pump assembly like it is on the first generation 91 to 96, as well as most other GM transmissions. So you need to be aware of that straight away. Nothing is interchangeable. You want to make sure that you don't actually accidentally put any gear parts into a late model from an early model and vice versa, because you risk burning up the transmission, you're destroying the gear train. All right, I'm going to get the case a little bit closer, or I should say the camera a little bit closer to the case, and I'll just walk you through how to determine exactly what year you're working with a 4L80E, and then we'll begin the teardown. Alright, so if you look right here, you're going to see the ID tag. All 4L80Es have this. Most of the time it's there, but unfortunately sometimes it's either missing because somebody ripped it off, or it's so bent out of shape, mangled, or illegible that you really can't see anything or make out what might be on it. But this one's actually in good shape. I just wiped it off with a rag. And by the way, don't use brake cleaner on this or anything else solvent-wise, because you'll actually take the paint away and you'll eliminate the 3-digit vehicle application code that you see on it. So this tells you exactly what vehicle it was installed into, and then the 2 digits located right here at the bottom in the center tell you the year. So this one says 94, it corresponds to a 1994 model year vehicle. Okay, so as far as dating the transmission, knowing what year production, because that's critically important for overhaul purposes, this is the best way to do it. Now, there's also going to be a sticker here, which in most cases is mangled, missing, or just simply illegible, but every once in a while you'll get one that the sticker's in good shape, especially for the newer 4L80s, 2008, 2009, that vintage on up. So this will have the same code as you see here, MDP, and it'll have a single digit in front. That's going to be an integer, and in this case it's a 4, which indicates 1994. Now if you see this same code, and let's just say this stamp is missing, but at the bell housing at the top there's a center bolt cast in, and there's a center lube design. You can see the cooler line fitting right here instead of both of them just to the immediate rear of the bell housing, then you're looking at a 2004 unit. Alright, let's do a quick walk around of the case. Here you have the part number of this transmission cast right into the case. I'll also flash the RPO codes on the screen so that you know how to identify a 4L80E. If you look in a glove box, you'll have a whole list of RPO codes, glove box in the vehicle, including the RPO code for that specific transmission that has been installed if you don't want to get underneath and take a look. Alright, so coming around to the driver's side of the case. Major difference between 94 and back and 1995 and up is going to be here at the selector shaft. 95 and up had the manual lever position sensors installed first year for the 4L80, and 96 they followed on to the 4L60. So the selector shaft was significantly longer. It did away with this kind of style linkage. It went to a cable shift linkage, and it had the MLPS, and in these two locations here they were threaded so that you can mount the manual lever position sensor over top or onto the selector shaft. So for purposes of retroing a transmission, you can go backwards from any year 95 and up into an older vehicle. You may have to do some tuning or some computer manipulation for the 91-93 model year, because they had that vented Bosch EPC that utilized a cleaning cycle, and I'll get into the specifics as far as the different parts that had applicability to inside the case. But for the purposes of just interchange the entire transmission, you can't take a 94 and back 4L80 and made it to any 95 and up model year vehicle unless you drill and tap the case for the manual lever position sensor. Okay, 91-93 they had 3 speed sensors for the 4x4 units. Okay, and 94 and up they did away with the output speed sensor for the 4x4 units. They still obviously had them for the two-wheel drive stuff, but in 91-93 they had the input speed sensor, they had the output speed sensor, and then in the transfer case they had the vehicle speed sensor. So in all 4x4 units, 91 through 93, the rear planet, the output carrier, had a reluctor gear pressed on to the carrier, and that is missing starting in 1994 for 4x4 units. So again, if you have a 4x4 and you're working with a 91 through 93 vehicle and you're looking to retro, you need to stay within your 91 to 93 model year unit if you're trying to just simply buy a used transmission to install in place of the one that went bad, if you're working with a 4x4 unit. Okay, so this one has a bolt-on yoke. Some of them have slip yokes, so this bolt is 3/4, and that's where we'll start with the teardown. All right, this should just come off or come out. Okay, this one's kind of stuck. There we go. Okay, so let's take a look at the yoke. As you can see, it's got kind of some issues here. This is mostly dirt. But you want to take your fingernail, you want to run it along the yoke surface. Okay, for a second I thought that that was a groove cut into the yoke by the seal. Okay, if you see that, then we would have to replace this yoke. It does have a parting line here, and I can barely feel, something, but I can't really feel anything that would lead me to believe that this would leak, and there was no driver complaints about leaks at the output shaft seal. Alright, yokes are easily to come by, and I'll just make mention to the customer to just keep an eye on this after it goes back in. If it leaks, then he'll have to replace it. Alright, the other thing you can do is just feel around the seal itself. I mean, this one's filthy, but if the seal is supple, then chances are, assuming the yoke itself isn't compromised in any way, there wasn't any leaks. Alright, seal's out. That took me a lot longer than I expected. So 15mm on all your extension housing and case bolts. Alright, if this came in with a transmission mount, in most cases the mounts are no good. So you want to counsel the customer to go ahead and replace them. Some of these will have an O-ring, some will also have like an oil slinger or oil retainer. It's like a silver cylindrical thing. It'll take an O-ring inside of it, so if you see that, then you know you need to put an O-ring there. This one does not have it, obviously. Okay, new O-rings will come in the kit. So this one's in good shape. I mean, it feels supple. There's, it's not like rock hard. Some of them come in, they're rock hard. Alright, so your pinhole seal will have to be extracted. You also have a rear case seal here with the snap ring, so once everything is out of the case, the last thing we're going to do is take the snap ring out and punch out that rear case seal. Now 4L60Es don't have a rear case seal like this, but the 4L80s and the 6Ls do. Alright, 2004 and up, they had a different bushing here. They enlarged the inner diameter of the bore on the two-wheel drive extension housing, so you will need to purchase an additional bushing if you're working on a 2004 and up unit. Otherwise, all you need is a complete bushing kit, and that will service all the bushings in the transmission which you need to replace on overhaul. Alright, speed sensor should always be replaced. You don't want to reuse that kind of stuff. Same with all the other electrical or electronic equipment. So your solenoids, your wiring harness, pressure switch manifold assembly. So 8mm on the speed sensor bolt. These speed sensors are exactly the same front and rear, so if you're having a no upshift condition out of first gear, it usually means the vehicle speed sensor has lost the ability to communicate information to the PCM, so the PCM isn't seeing anything coming from that speed sensor, has no idea how fast the vehicle is moving, so it will not allow for any upshifts. It basically gives you first and reverse, and that's it. So a simple way to try and diagnose something like that is to switch the speed sensors. If all of a sudden you can shift, but you have ISS related codes or gear ratio codes or whatever that would indicate that the front speed sensor is going bad, then you have identified the problem. My recommendation, I make this in a couple other 4LADE videos, is I would keep a pair of speed sensors in the vehicle with you, along with a manual lever position sensor, if so equipped, so that you can quickly replace them in the field or on the road in the event you have problems. All right, 15 millimeter on the selector shaft nut for the linkage. And that nut does not want to come out of the socket. All right, I'm gonna go grab the slip yoke again. I'm gonna turn this around because then what we're gonna do is we're gonna look at the front, but real quick, if you're having issues with any kind of trouble codes corresponding to the transmission, particularly solenoids, check this case connector. Sometimes they like to leak through the connector, and that will short out the pins, and as a result, it will throw codes or put you into limp mode. And limp mode is anything where you only have second gear. Trash truck. You only have second gear and you'll have reverse. That's limp mode in a 4LADE. So if this is leaking, that may happen. You'll just need to replace the harness. So we're not ever going to reuse harnesses. So all you need to do is just punch it in. That will destroy all the locking tabs, and then once everything's disconnected on the inside, you can just pull it through and throw it in the trash. Okay, check this area too. I see some rust on the shaft. We'll look at it more closely when we get it out. Let me go ahead and remove the line pressure tap. So if you're having issues, drivability symptoms, slipping and whatever, take this tap off, stick a transmission pressure gauge in here, and go ahead, start up the vehicle and take line pressure readings, both while sitting in park and driving the vehicle if you can. If you have a long enough hose that will allow you to drive the drive the vehicle around with this plugged into the transmission, so that you can see what kind of line pressures you're getting in each gear. So 7/16. All right, so now we have the front of the transmission. What I'm going to do is I'm going to stick the slip yoke back onto the output shaft. Now output shaft's filthy, that's why I was having trouble. I'm also clumsy, so two factors. Anyway, the purpose of doing this is so that we can spin the output shaft and the input shaft to see if there's any kind of issues internally. And then what I'll do is I will hold the output shaft steady and still while I spin the input shaft, okay? And what that will indicate if the output shaft wants to spin with the input shaft is a potential bind up inside the case somewhere. So 4LADEs are very difficult to spin the input shaft by hand if it's used like this. So first thing you want to do, actually, I should have mentioned this. First thing you want to do is just go like this. Okay. Front end play should be between 4 and 22 thousandths. Rear end play should be between 5 and 25 thousandths. You never ever want to have more rear end play than front end play. And when you do front end play, you gotta kind of load the rear of the transmission. In other words, force the gear train forward. Then you have to net out the little bit of gap that exists between the snap ring on the rear of the input shaft to the overdrive planetary carrier, and then you take your reading and you do your math, and whatever's left over in terms of travel, that's how much front end play you actually have. So this one feels pretty tight, which is fine. I mean, you're not going to be able to feel 4 thousandths of an inch by yourself if that's truly all that was there. So we have the rear gear train, we have that snap ring, and then we have whatever is left over. So I'm just going to tap the output shaft on for a little bit, and then what I'm going to do is I'm now going to spin the input shaft and hold the output shaft. Okay, here we're going clockwise. I'm going to spin it counterclockwise, and as I'm holding the output shaft, I don't feel any kind of movement. My left hand, it doesn't want to spin against me or force against me. So now I'll spin the output shaft and hold the input shaft. Okay, input shaft's going to want to spin, just so you're aware, but you should be able to hold it steady. It should not want to force its way out of your grip, okay, when you're spinning the output shaft. Okay, the input shaft should not want to spin while you're holding it, tightly. Okay, you can even turn it in the opposite direction as the output shaft. Either way, the point of this is you want to make sure there's no binds in the case. That's all you're really trying to do here. Okay, pump to case bolts. They get 13 millimeters socket. Okay, before you do that, check this converter clutch circuit O-ring. I yank it off because you're never going to get the pump off the input shaft without this thing, still being on there. If this is like flattened and rock hard, then more than likely there was leaks at the converter clutch circuit. So when the converter was supposed to be applied in trans and lockup mode, so to speak, it may have been slipping, and that usually generates a code P1870. There may be other codes associated with the torque converter circuit or converter itself that may set and store if this O-ring is no good. None of these bolts should be loose. Okay, 20 foot-pounds on all these bolts when you go back with it. And they all have little seals just underneath the underhead radius of the bolt. Alright, so that's more or less dealt with. Alright, cooler line fittings are 11/16 on these. On later models, the center lube design, they're kind of the quick disconnect variety, so they will be 3/4. Alright, so now we're in position to go ahead and flip this thing over. We'll take the pan off and take a look and see what we find there. I'll go over the differences between first and second generation valve bodies just at a high level so you can get a good sense for what that is. I mean, if you've seen these before, it'll be readily obvious, but then we'll kind of proceed taking everything off the belly and then going into the barrel of the case. I mean, these are pretty straightforward to tear down. There's not a whole lot complexity-wise, so it should go fairly quickly. Alright, so these transmissions are big and heavy, so you just kind of want to be careful, making sure that the thing's not going to fall off the bench. You obviously want a sturdy bench so that you don't have those kind of mishaps. Alright, we'll let a little bit of fluid drain out. So the pans are different between the first gen and second gen transmissions. First generation transmission, as you can see, the pan is more or less flat and uniformly dimensioned throughout the entire length of the pan. The overall shape is the same. However, on the late models, if you watched my other 480E teardown video, you will see the pan is beveled and contoured toward the rear. Okay, you'll see a big feed pipe going from the front of the valve body to the rear. That is the primary driver behind that difference in pan shape. Seventeen 10mm bolts. Okay, 98 to 108 pounds on the torque when you go back. Put the pan back on during reassembly or as part of a service. Oop. didn't want to come out. It had expressed some displeasure. All right, woo. So it looks like I made kind of a mess. Let me clean that up right quick and then we'll resume. Okay, so I just got done talking about the bench. Just to be clear, this bench is like bare minimum of what you should have when working on transmissions 4L80E class and larger. Bare minimum, and I would say it's probably not good enough for anything bigger than a 4L80E. So when I'm doing my big Ford transmissions or an Allison, I just put the thing on the stand and that's where I tear it down. So you know, I don't mean to go off on a long soapbox here, but what this is telling me, you know, having all that fluid rush out and spill out all over the place is, hey dude, you need to get a different bench, a better bench, you need to upgrade. So anyway, this pan's obviously fallen off, but if you're tearing apart transmission, you go to take off the pan, maybe somebody put a whole bunch of RTV on here, you want to make sure that you go in at a bolt hole location so that you don't risk damaging the pan. So take a flat blade screwdriver that is not grooved, where the blade is nice and smooth, and go ahead and just gently tap on each bolt hole location until the pan starts to come loose and you can take it off. If you bend the pan here or damage the pan rail sealing surface, or at least bend it, not damage it, but just bend it a little bit, when you go to put the pan back on and torque down that bolt, it'll flatten it out for you. In most cases, if it's severely bent, then you're going to want to replace the pan. Okay, customer did advise that he dropped the pan initially to just drain it of fluid before he removed it, so we're not going to see a ton of evidence, but the fluid is, it stinks. Something is burnt in here, and he advised that there was a whole bunch of black clutch material. I mean, you could see a little residual matter there. There's plenty of gunk on the magnet, so what little evidence we have to look at, there's definitely issues here with applied elements in addition to the aforementioned harsh and really abrupt shifting. All right, let's go clean up the floor. Let me get some of this fluid into the trackway so it could drain into the catch pan, and then we'll start taking stuff off here. So as you can see, we have the large feed pipe going to and fro from the front of the valve body into the rear of the case so that we can lubricate that rear case bushing during operation, or I should say it can lubricate the case bushing. We have a dipstick stop. The filters themselves were largely the same. The electronics were largely the same. Like there was no wholesale changes in things like solenoids, the pressure switch manifold assembly, things like that for the 4L80E's life cycle like there was for the 4L60s. The 4L60Es, they underwent significant changes from a command and control and solenoid sensor perspective. Starting in 2009, they did away with the pressure switch manifold assembly and manual lever position sensor, and they went to an internal mode switch, which the 6Ls, the 8Ls, and I believe the 10Ls, I've never rebuilt an 8-speed or a 10-speed, but I believe they use pretty much the same thing. So this is the original filter. Obviously it was not changed, so a good practice is to cut these open whenever you do a service, just to check to see if there's anything floating around inside, like pieces of metal or anything unusual that would lead you to believe there's an issue mechanically deep inside the transmission. So I mean, we're not going to do that here because, well, we're going to tear apart the whole thing. So this gasket is a bonded steel and rubber gasket, so you have kind of a steel layer here on the sealing surface, and then you have rubber all around. These are technically reusable, though I'm not going to reuse this thing. It's it's pretty old. On the late model teardown video, I didn't mention it, but that had been serviced at some point, and somebody either took or threw out the bonded gasket and didn't replace it with any equivalent. They just put a standard composite gasket on it. Not the greatest of things to do. That's why I do all my own work. You never know you know, who's ever working on your vehicle, what they might do. Even little things like that would bother me. So, all right, wiring harness. Obviously, you're always going to replace your harness. You'd never reuse any electronics in the transmission on an overhaul. Every single electrical or electronic component inside the transmission gets replaced. I'll have to check the impedance on these sensors and solenoids, but 1 and 2 shift solenoid and the you know, they take between 20 and 22 ohms, at least for the later models. It's been a while since I've worked on a you know, model this old. Then you have your PWM solenoid, that's between 9 and 11 ohms, and then 4 to 5.5 ohms for your electronic pressure control solenoid. Okay, here is your transmission fluid temperature sensor. If that goes bad, you'll get codes for that. So now we have the wiring harness out of the way. All right, we'll throw that in the trash. The harness that we're going to replace that one with is made by Rostra, and their harnesses for 1991 through 2003 will service the 91-93 model year units as well as the 94 through 03. So it's, you know, one harness for all those years, first and second generation 480. All right, I'm going to start taking off all the bolts. So we have 10mm bolts. All these are the same length. And you have 6 8mm bolts for the pressure switch manifold assembly. So let me actually get that off first, and then we'll take off the rest of the bolts and remove the valve body. If you're not super familiar with working on these, maybe it's your first time, you may want to take a picture of everything other than when the filter, you know, take that away, but take a picture of the harness and everything else, the way the harness is routed. I mean, it's not super complicated, but again, for someone that's just starting, it's not going to be as straightforward as with somebody that's, you know, been there and done that multiple times. And that's true of any transmission. You know, some are a little bit more complex on the belly than others. You know, got all different types of wires going everywhere. You can maybe got feed pipes, and you know, it looks like a zoo. So it's always good to take a picture. All right, pressure switch manifold assembly. These did not change. I have a video that shows you how to test this thing if you're getting trouble codes associated with the pressure switch manifold assembly. During overhaul, they get replaced, just like all the other electronic stuff. So, socket was about to slip out of my hand, fall on the ground. Alright, so here is your dipstick stop. Okay, this is typical what you would see on early units. And then you have your hold down for the front end of the pipe. I'm going to round this off. Okay, I have tons of these bolts. I'll just put another one on, put that aside. In the event you round off a bolt inadvertently, like to where it won't come out at all, what you want to do is take like a cutoff tool, you know, with a small abrasive cutoff disc, and just cut a slot in the bolt. Okay, just, you know, a slot going all the way across. By itself, the heat by itself will a lot of times loosen the bolt for you, but if not, just take an impact driver, just a manual impact driver, you know, with an impact driver bit, flathead, you know, and then smack it as you're turning the impact driver counterclockwise. You know, a couple smacks with the hammer and the bolt should come right out. So if that had been the case here, you would have seen me demonstrate what I'm referring to. Okay, no particular torque sequence on these bolts. What I generally will do is just go start in the center and work out in a spiral pattern, and then I'll just go to check them all row by row until I've gone through them all twice. So 98 to 104 inch-pounds. Year of production is available. It's going to be found right here in this location. I mean, you may not be able to see it because this pipe is in the way, but let me get the pipe out of the way so that we can get the valve body off to begin with, but it's going to be right here. Okay, check balls are in the case on the other side of the spacer plate. So if you're dropping the valve body, you're probably going to want to have a diagram that will show you exactly where the check balls go. I'll move the camera so you can see it, and if you want you can take a screenshot. To my knowledge, there was no changes in check ball location orientation throughout the entire production life cycle of 4L80Es. You can leave some check balls out depending on what you're doing with the transmission, how it's being calibrated, and maybe you're installing a shift kit that calls for the check balls, some of them to be removed, and so you may see something different. If you haven't done so already, and you plan on working on 4L80Es for some degree of frequency, I strongly recommend you buy ATSG, the Automatic Transmission Service Group check ball book for the domestic transmissions, and it will have all the different check ball configurations from the factory that will show you the location of each and every check ball, whether we're talking about check balls in the case, check balls in the valve body, check balls that may be located elsewhere like an auxiliary valve body. As long as there's a check ball, it will show you the location and the specific designation for that check ball, so it's an invaluable resource to have. All right, now I have the case out of the way and most of the other stuff. We can take a quick look at the separator plate to see if we can better understand why this transmission was bang shifting in first to second and second to third gear transitions, because that was really the only complaint. So just a little bit of the background and context on the 4L80Es when it comes to mechanical shift calibration. The only thing you really need to do with a 4L80E, especially if it's otherwise stock, in other words unmodified, to achieve or get firmer shifts, is to drill the feed orifices for your 1-2, your 2-3, and your 3-4 upshift transitions in the separator plate. Okay, that's it. That's all you have to do. You can leave the valve body alone. You can reinstall the accumulators as is, make no modifications anywhere else in the transmission. All you have to do is drill those 3 feed orifices. The 4L80E is very sensitive to the size of the orifice, meaning the effect of enlarging a given feed hole, 1-2 or 2-3 or 3-4, in terms of percentage of what it was prior, is going to be disproportionate relative to what you might think. In other words, enlarging, say, the 1-2 shift feed from what I think is 50 thousandths of an inch factory to 60 thousandths of an inch factory is going to take a relatively soft shifting 1-2 transition to something that probably borders on along the lines of bang shifting. Okay, it's going to be pretty close to where it feels like it's bang shifting, especially at part throttle, very shallow throttle angles. That kind of driving that you're going to do most of the time, especially in a heavy duty vehicle. Okay, maybe you're on the road a lot, but most of the time, especially in the earlier parts of the drive cycle, you're going to be shifting a lot, and it's going to be borderline brutal. And that's with a factory converter. Okay, with a factory converter. Okay, same with the 2-3, although the effect is a little bit less, which means you can drill this a little bit more than you would the 1-2. And then the 3-4, the effect is a little bit less than the 2-3. So, if you're noticing a pattern here so far, not only do you have to make good decisions about how much to widen these feed holes, you have to also understand they should be widened in relationship to each other, and that there is kind of a ratio, if you will. So the 1-2 should, all other things equal, be your smallest diameter feed orifice. And then if you're not dual feeding the direct clutch, you want to kind of step up, but only just a little bit with the 2.3, and then I would keep the 3.4 the same as the 2.3. Okay, but the 1.2 should not be as big as the 2.3, all other things equal. Now, if you're dual feeding the direct clutch internally, you want to drill this out a little bit more because you need more fluid to get into that chamber faster so that it can apply the clutch faster. Okay, because when you dual feed, you're taking away that partition represented by the seal in the center of the drum. So at that point, you need more fluid volume to have the same effect. Now, this is what a factory stall converter. Okay, to give you an idea of what we would do and how sensitive the feed hole sizes are for high performance or racing, just look no further than my 4L80E rebuild video that's on the channel now, that yellow transmission. Okay, I drilled the 1.2 feed orifice to 80 thousandths, the 2.3 feed to I think 85 thousandths, and the 3.4 to either 80 or 85 thousandths. It's going to be in that general range somewhere. Okay, that's not a huge departure, but it's intended for somebody that's going to be running a 3200 stall converter and racing this thing down the track at 6,000 RPMs. Okay, for a factory application like this, there's no need to go anywhere near that big. So let's see how big these feed orifices are. And keep in mind, a factory spec plate is going to have between, I want to say between 48 and 52 thousandths on all the feed orifices. Okay, so here's a drill bit that is 64 thousandths in diameter. Okay, here's your 1.2 feed. Okay, this fits in there without any issue at all, with plenty of space all around. Same with the 2.3. This looks like it's even wider. It will not fit in the 3.4. So the 3.4, just by eye, looks factory to me. That looks like it's about 50 thousandths. Okay, the next object we're going to use is this roll pin punch. Looks like it's right at 70 thousandths of an inch. So 1.2. Okay, this is dragging on all sides, so I would say this hole is 70 thousandths of an inch wide. And then you can see with the 2.3 it fits nice and easy. You know, this is probably something on the order of 75, 76, 77 thousandths, somewhere in there. So here's an unmodified factory plate, just for comparison purposes. So you have your 1.2, you have your 2.3, and you have your 3.4. And as you can see, the feed orifices are significantly smaller from the factory. Okay, our 60 thou drill bit will not fit into any of those holes. All right, and incidentally, this is a second design spacer plate. In other words, it goes to the second generation 4L80Es, 97 and up. And how you can tell real quick, if you don't already know or you're not sure, just look at the corner here, right to the left of the accumulator housing. Okay, on a first design, you're going to have a big circular cutout that's for that feed pipe, and then you're going to have another cutout that's kind of trapezoidal shape right below it. In the second design plates, there's nothing up there. I haven't scrutinized these two plates, or any first or second generation plate side by side, so I don't know if all the other holes and cutouts and everything else is exactly the same. If they are, then you could probably take a first generation spacer plate and prospectively install it into a second gen case, but that's assuming that everything else is identical and there's no conflict with bolt hole locations or anything like that. Like I said, I don't know, some of you guys probably already know this, but either way, use caution. I just wanted to show you what the difference was and how you can tell. All right, so the bottom line here, we're going to install a new spacer plate. If I have a good factory first generation plate, we'll go with that. If not, I'll purchase a Transgo plate. All right, I'm going to go through the valve body in a separate video. I don't have any 4L80E valve body disassembly, reassembly videos at this point on the channel. So this will be a good opportunity to make a couple of them. We're going to test that valve body with a Sonex vac test plate along with their test machine. Now, when I test valve bodies anymore, I will test the valve body before and after I finish going through it. So before, when it's, you know, still all nasty and dirty, I'm going to wipe the worm tracks off, but I'll test it beforehand, and then I will go through, overhaul it, do whatever I'm going to do with it, install, you know, different valves or whatever, and then I will retest it again just to make doubly sure that it's good to go and it's not going to cause any problems for the transmission when it goes back in the vehicle. Okay, this is going to be your low reverse housing. So this is the cover. You're going to have your low reverse piston in here. Then you're also going to have your 1-2 accumulator. So we'll look at that spring. My guess is that it's fine, but we'll see. One of the dangers of excessive line pressure in the transmission is the breakage of parts. All kind of parts can break. I'm hoping there's no issues with the case lugs or the intermediate clutch or the pressure plate, but you know, pressure plates are everywhere, but don't want to have to go looking for another case if we don't need to do that. Okay, so the covers between the first and second generation transmissions are not interchangeable. And the valve bodies are not either, by the way. Valve bodies, covers, they're all different between your 91 through 96 first gen transmissions and your 97 and up. So you don't want to try to intermingle them. Between within the generations, but between the different vintages, 91 through 93, they used a Bosch vented electronic pressure control solenoid. So that necessitated some design attributes that were organic to that vintage. And so I believe not only the valve body was different, the spacer plate was different, obviously the EPC was different, the harness was different, and the case itself I believe was different as well. And then 94 and up, they went away with that vented design. They transitioned to the Borg-Warner non-vented design, which is what you just saw. And the spacer plate, the valve body, and I believe the case also changed. Now, if you go on Transgo's website and you look up instructions for their 4L80 shift kits, they contain some procedural information for how you can adapt a 91 to 93 to the 94 and up standards. Check those out. I'm not going to get into them now because I'm not going to show you hands-on, but they have that information there for you in the event you need to replace a 91-93 EPC with the Borg-Warner style so that you can do what you need to do with the valve body and or spacer plate. And I'm going to just get rid of some of this excess fluid. And then this is going to be your intermediate band servo for manual second. This design changed, starting, I want to say in 2001 they had a wider band, so they have a completely different servo, longer pin, and you can retro that wider design back to any year 4L80. You just have to retro the band and the servo assembly and spring and all that. That would be an example of a service pack. So you have groups of parts that work together. All right, I'm going to take the parking linkage out, and then we'll deal with the two feed bolts. So 13 millimeters here. Just make note of the orientation of your parking pole guide plate. So it looks kind of like an easy chair or a bus chair. The chair is oriented toward the, toward the side of the case. Get all the stuff out of the way. The 1-2 accumulator spring is in fact in good shape. We'll go through that a little bit once I get the rest of this stuff off. Okay, 15 millimeters on the rooster comb to selector shaft nut. So we just take that loose real quick. And then this nail, you have to be real careful with how you remove it. All right, you want to be mindful that it can break on you. So what I like to do is take a soft hammer and a pry bar. I'll just get right underneath the underhead radius of the nail, and then just gently tap up on it. And 2 or 3 smacks, it usually comes out, and you usually won't bend it. Alright, so here's your servo assembly. If you have issues with no reverse, you're going to want to check your seal here. Okay, if you have leakage at the seal, if this is rock hard and feels like plastic, then just replace the seal and put everything back together, see if you have reverse. Here's the 1-2 accumulator piston. Okay, you want to check these seals. Now, 4LADEs, these seals are rubber. In the TH400s, they had those Teflon seals, or sealing rings rather, and sometimes they could wear out. So, if you don't replace those seals on overhaul and you put it back in and you have slippage, on the 1-2 shift transition, then chances are it's because you didn't replace the seals on, on the accumulator piston. All right, very slippery, so gotta grab a paper towel. All right, it's always good to kind of check that stuff out, make sure that it's not what's causing your problems, whatever they may be, or whatever symptom patterns you've had. You want to be sure to identify the causes of any sort of symptom patterns so that there's nothing undiscovered that when it goes back in would cause a reemergence, of those issues. This thing's being stubborn. All right, there it goes. I'm gonna fish it out. All right, so here's the servo assembly, and this just comes out just like this. Okay, the assembly is different. You have your washer here, so this washer goes like this, and the rest of it's like this. Okay, this is markedly different than the 97 and up. They have another larger spring in here, and they also have like a spacer, a sleeve that goes on the end of the pin. And then these pins are significantly different lengths between first and second generation, so they're not really interchangeable per se. You want to use caution. I'll do a separate video on how to measure for and adjust servo pin travel so that you can be sure to get that correct. But for the most part, this is a general rule of thumb. You still want to check on overhaul, so don't think that this means you don't need to bother with it. But general rule of thumb is if you're not replacing the the front planet and you're replacing the band, but there's no other changes you're making, you should be okay with respect to servo pin travel. The clearance between the band and the drum portion of that planet should be where it needs to be. That's not a guarantee. It still needs to be checked, but it should be. Okay, and you're not replacing the case either. So if you're replacing any of those parts, you definitely need to go through the process of measuring for and adjusting servo travel so that you don't either burn the band up or you don't have a no apply condition. So you have a lot of latitude, but you still need to check because you don't want to have to deal with it twice. All right, let me get all this crap to the side. This out of the way. Okay, always replace your metal gaskets. They come in the kit along with all your other paper and rubber stuff. Alright, with the nail out of the way, we could take the selector shaft out. Just undo the castellated nut. So this selector shaft looks okay. I mean, it's got a lot of grime and dirt and whatnot on it, so we'll just clean that up and inspect it further. But for the most part, they're okay. Now, the selector that's shown in my other 480 teardown video, that thing was just destroyed. I elected not to use it. I just threw it in the trash. Nut. And then just make note of the arrangement of the rooster comb on the parking rod assembly. Okay, now these all have rivets. I didn't mention this in the other video, but I'll mention it here. You want to check this too. In fact, I don't think I mentioned this in any of my teardown videos. I should, but you want to check this here. If this is looking like it's starting to mushroom out, you'll want to replace this, because if this actuator here, the end that's spring loaded, comes off, then the driver will never be able to put the transmission in park. And you don't need to be a rocket science to figure out all the problems that can occur as a result. Okay, so I'm going to leave this spring in here, and I'll show you how it's oriented, because when I take the gear train out, I don't want the pole getting in the way. I stupidly took it out in my other video, and I mean, it was no big deal, but still, it's a good practice just to leave this in here for now. Alright, so we have a Torx 40 here, and then we have a 3/8 12 point here. That's the sockets that we require to get those respective feed bolts out of the way. So this is the overdrive feed bolt, Torx 40. Make sure it's in there. And then put a little bit of inward pressure just so the impact doesn't want to jump up and strip the bolt out. Alright, so this looks good. New ones come in the kit. The Transgo shift kits come with these bolts also, but they use like an Allen head design, and I do not like them. They tend to strip out. I've stripped out a couple myself before I finally said, you know, enough's enough. I'm just not going to use them. So if you're installing a Transgo shift kit, do not use those bolts. That's my advice. Just use the new factory style Torx 40 bolt that comes in your kit. Okay, same with this thing. Apply a little bit of pressure. All right, this is in there. Okay, a new bolt comes in the kit, I believe. I'm going to stick that in there for now. So now we're in a position to basically turn this thing around and take every single thing out of here. The case is fairly straightforward to evacuate as long as there's nothing broken inside. In a 97 and up 480E, you want to be, I guess, mindful that you need to take out the rear cooler line fitting. One time I was disassembling one when I first started building these. I had everything out of the case except for the gear train. I took the feed bolt out and the center support snap ring out, and nothing would come out. Like, I was wondering what the hell was going on. I thought maybe it was grenaded or something was holding it back, because it should just all slide out as one giant assembly. Anyway, I was just about to do something really stupid and, you know, really drastic when it dawned on me that the return cooler line fitting goes into the center support, and that's what was holding it back. So, you know, just a little anecdotal story there. But something like that can trip you up if you're not familiar. And back then, I was not super familiar with 480s, having only built, I think, 2 of them, and they were both of this earlier first gen variety. All right, let me clean the bench up a little bit. We'll straighten the case out, have the pump face the camera, and then we'll start going through the case. All right, we'll start with the pump, obviously. Again, make sure that torque converter O-ring's off. And then you're just going to take a pry bar, and you're going to come right in here on either side of the pump to get behind it, and just gently start prying it forward. Okay, it shouldn't take too much effort. I mean, there shouldn't be any signs of it being stuck or seized or whatever. You know, it's going to take a little bit of persuasion, and that's basically it. Alright, now when you do this, you're probably going to tear the pump to case gasket, but if you don't, if it happens to come out in one piece, which this one did not, but if it did, you want to have a quick gander at it. And I say this in all my videos, but you know, you want to take a look and see if there's any kind of signs of blowout here. Okay, so as you can see, this, I don't know if this is machined or not. I'll have to take a look at a new pump gasket. It's escaping me. I think it is actually. But if you see blowout, yeah, it is. Because there's identical sections cut out on these other locations. But if you see blowout, it's another sign of highline pressure. I don't see it too often, to be perfectly honest. It's just something that you can look at as just another piece of evidence to point to one condition or another in the transmission. Okay, so as you can see, we have the older style. We have the older style one-piece sealing rings. These require a special tool, and so I have that tool, but it's almost never used because I use the excuse me, I use the new style that come in all the kits, and you know, I've never had issues with you know, problems or whatever. But this is going to be something that unfortunately is not available anymore. At least not that I've seen. This is selective, so it's always a good idea to have a couple of different thicknesses of selective pump thrust washer so that when you go back together with it, if you need to make an adjustment, you can. And that is to set your front end play. All right, next we're going to pull out the input shaft slash overdrive section. So this is going to be your coast clutch drum. You have your coast clutch pack in here. You have your overdrive roller clutch assembly. This is going to be your overdrive planet. All right. If that overdrive roller assembly fails, you will have no movement in any gear, any range. Okay. So you can hear the one-way clutch. It's going to freewheel counterclockwise, and it's going to lock clockwise. Okay. And that sound is the sound of a healthy roller clutch. Now, I always replace these roller assemblies. I never reuse them, but this one sounds like it's fine to me. Check the sealing rings on the forward drum. This is for the forward clutch circuit. If they're bad or they're flat, then any kind of you know, delayed engagements in first or slipping in first or similar complaints to do with takeoff could be the result of wear here. All right, and then same here, check these sealing rings. I mean, we'll pull this apart and look at them more carefully, but check in here too for any wear on the sealing surface for the stator sealing rings that you just saw. But I usually don't see any problems. It's pretty rare. All right, make sure that that stays put. All right, next is going to be the overdrive clutch and clutch housing. So you have your piston and your piston housing, and then of course you have your clutch basket with your frictions and your steels. All right. Now is your forward drum. Okay. Sometimes the direct clutch hub right here, this will get, you know, a little bit caught up. You'll have to use two hands to take it out. Notice your bearing and the orientation. Okay, we'll take a closer look at this later, but one of the things you definitely want to check for is sealing ring groove wear cut into the inner diameter here. Okay, any kind of no forward movement or delayed engagements into forward and the drive, it's going to be a combination of worn sealing rings and grooves cut into that inner diameter. All right, this plastic thrust washer, this goes here onto the forward clutch hub. So it goes like that. Okay, forward clutch hubs in TH400s. I recommend that you swap in a billet equivalent that's rollerized whenever you have, I would say, more than about 450, 475 horse in a racing or street strip application, or a very heavy duty application such as, I don't know, like a box truck, a school bus, a snowplow vehicle, something along those lines where it's going to see a lot of stresses. So for our ladies, the billet hub's a little bit more resilient. So north of 550, say 600 horse, I'm swapping in a billet component. All right, so direct clutch, and then the sun gear shaft's going to come with it. I'll just put that back in there for now. So direct clutch drum, just check around the band surface here for the intermediate band. Usually not an issue. Again, we'll take a much closer look at that later. I didn't mean to smack that like that. And then, of course, you have your intermediate band. All right, later models, 01 and up, they had a wider band, and we can see a little bit of wear here on the band. You know, see a little bit of heat wear, heat-driven wear. All right, now we have the intermediate clutch. So let me zoom in a little bit, and I want to see what that clearance looks like. You know, what it feels like, I should say. It should be around 40 thou or so, and I don't think that the clearance is going to be why this thing shifted so harshly from first to second, but you know, we'll check it. So I'm going to zoom in. Okay. The clearance to me feels like it's between 50 and 60 thou. So, see if I can get a good visual representation. It's going to be tough looking at the camera, at least, you know, at this angle, but I don't think that the intermediate clutch clearance is going to be our problem here. I think, B&M shift kit being installed, hole sizes are probably enlarged. We'll take a look at that when we disassemble the valve body. All right, and I'll zoom back out. All right, now that we've kind of inspected the intermediate clutch as far as clearance, let's go ahead and just remove it. So I'm just using a screwdriver here and grabbing on the intermediate clutch snap ring. This is something you always want to upgrade, even if you're just doing a stock rebuild. I like to use Chrysler A518 direct clutch drum snap rings. Usually 88 thousandths thick. I mean, they're selective, so there's, I think, 6 different sizes, but the 88 thou to 98 thou thick snap rings are what I most commonly use in 480Es, okay, and TH400s. I think a couple of times I've had to use like a 110 thousandths thick snap ring, but that was pretty rare. All right, so here's the clutch pack. You have your backing plate. So you just want to check the backing plate, make sure it looks good, aka pressure plate. And then you're going to have 4 frictions and 4 flat steels. All right, so that friction looks in good shape. No signs of slip marks on the steels. These are Borg Warner. So the 480Es and TH400s, you really don't need anything beyond factory level frictions, even for high performance, up to a certain point. Like I would say, like occasional racing horsepower at 600 and below, factory frictions, believe it or not, will survive. Okay, you got a little bit of signs of heat right here on the frictions. On this bottom friction. Take a look at that other one. I think we saw the same thing there too. A little bit of heat. Nothing too major. Nothing that would lead you to believe that the clutch wouldn't work. But that's the intermediate clutch pack. Like I said, we'll go through all the clutch packs in a little bit. So intermediates look good, at least at first glance. All right, so now we have the center support. One difference you'll notice is that there is no cushion plate. So the 97 and ups, they have a cushion plate there, and I'm almost positive the center supports, the intermediate clutch piston changed as well, but I could be wrong. I'll have to double check and I'll annotate if so. All right, so let me get in there and see where I need to see engagement wise for the center support snap ring. Oop. Come on. It's getting stuck on one of the lugs. Alright, there it comes. Alright, a little sloppy again, but you want to make note of the bevel. The bevel side faces front, and then the flat side of this thing faces rear, faces the center support. Alright, so at this point, the entire gear train should just come right out of the case. So, like I said, I left that parking pull spring so that it wouldn't interfere with what we're going to try to do now, which is simply take the entire gear train out and stick it on the bench, and then we'll start going through that first and work our way through the rest of the sub-assemblies. First things first, I'll take the seal out of the rear of the case, so that snap ring and that rear case seal. So this is heavy. In fact, if you're going to build 4LEDs, TH400s on any kind of regular basis, even to be honest with you, even just once, you want to get a lifting tool for the gear train. So this tool goes in behind the intermediate shaft like this and just kind of sits there, and that allows you to lower the whole assembly into the case in one shot and do it in a way that's safe. Now, you can use certain types of vice grips to accomplish the same thing, but the tool is only about 30 bucks, or at least that's what it cost when I bought it years and years ago. Maybe they're more now, but you definitely want to have something. Okay, so just carefully handle it. Alright. And then I'm going to take my both hands and lift it out of the case. So as you can see, straight away we have issues with the band surface on the front planet. So that's going to have to be either turned or swapped with a used planet, because I'm not putting this back in here like this. Nobody would and nobody should. These are, pretty deep ridges. So we look forward to replacing that. And then a couple other things left inside of here are going to be your anti-fretting ring. Let me fish that out. This is going to be your anti-fretting ring. What this does is it sits on the case on the immediate back side of the center support here, and it protects the case from the wear that would otherwise occur as a result of those lugs kind of thrusting against that portion of the case. Real old TH400s, they did not have that. The lugs here were thicker, so you would have to check for lug wear, but more importantly, they used to wear the case pretty badly. The practice is to retro a later center support from a TH400 after, I want to guess, but I'll put in the annotations for those that are watching this. Chances are you're interested in TH400s as well. The practice is to retro a second design center support along with an anti-fretting ring into a case that originally took a first design center support with the thicker lugs. Okay, then the band is in here. Alright, here's the band. Alright, many shops consider this band a hard part. So it's not replaced unless it's necessary. So if you're wanting to reuse your band, maybe you're on a budget, you want to check right in here. This is where you want to pay most attention to the band, because this is where the apply surface is, and that's where it's grabbing, and this is what is typically worn. So you want to dry the band off with a shop towel or something, and then carefully scrutinize it for any damage if you plan on reusing it, because typically the rest of the band is okay. Now, when I see a lot of warpage and damage to the surface like this, I mean, even if I was maybe planning on reusing the band, which I never do, I always replace all soft parts and or friction material. But let's just say I would not reuse that band. Alright, last thing in the case is going to be the 3-tab selective washer that is used to adjust rear end play. And it's also fighting me. Everything's fighting me today, so let me go grab a pick. Okay, so here's that 3-tab thrust washer. It's steel and it is selective. There's multiple different thicknesses available. So like I said, rear end play or travel, that gear train needs to be between 5 and 25 thousandths, and you must have less travel in the rear than you do in the front. And that's net front end play, after you net out the rear and you net out you know, the snap ring that sits on the other side of that input shaft, because that has a little bit of travel as well, as you saw earlier. For all my 4L80Es and TH400s, I basically delete these two things and I replace them with a TH350 pump bearing. You put the pump bearing into the case, like quote unquote upside down, so that the silver side of the bearing faces up or faces forward. But what you want to do is you want to measure the thickness, combined thickness of these two washers, and then you will add a shim or 2 shims to your bearing, just as a place to start when it comes to measuring for rear end play. You can take this 4-tab washer and install it on the front of the output carrier in place of the plastic one that's in there. I will generally do that on all my builds because it tends to tighten up the travel between the front and the rear planet, and at the same token, because it's Babbitt, it's a little more resilient to heat in the event there's some overheating. Okay, hopefully there's never any overheating, but you know, sometimes that does happen, especially on a heavy-duty transmission like this. I mean, you know, you're doing a lot of towing, you're doing a lot of hauling, maybe you live in a hot weather climate like I do, and you know, is what it is kind of deal. All right, so now I'm going to take off the you know, the little parking pull spring if I can. Let's see, maybe it doesn't come off. There we go. Alright, so this portion is what actually engages the parking pole, and when you go back with it, you want this opening facing to the rear of the case. Okay, so this faces the rear of the case, and this goes on like that. Alright, let me put the case in such a way that I can get it the snap ring. And then let me move the camera, and we'll go ahead and remove that rear snap ring and pull the seal out as well. Alright, before you try to remove the snap ring, what I found to be helpful is tapping the seal inboard a little bit so that it's not kind of wedged up against the snap ring, making it harder to get out of the groove there. So you could use whatever to do this. I'm just using a flat blade screwdriver, and you're not trying to get crazy, you're just trying to move it off a little bit so that you don't get caught up in the groove when you're trying to take that snap ring out. Sometimes this helps, sometimes it doesn't. Alright, you don't have to be super aggressive. You just want to see if you can move it off a little bit, and then you're going to take some snap ring pliers. Okay, these are Snap-on SRPC 9000A. Or equivalent. And then you're just going to take it off. When you go to reinstall this thing, what you do is you kind of situate the snap ring in after you put the seal in part way. Get it as square as you can, and then stick the snap ring right on top, and then use your bushing driver that's appropriately sized and just tap it on in. And as soon as you get past this groove, the snap ring will seat right into the groove. Okay, to pull the seal out, I mean, you could do any number of things, but excuse me, I like to use, you know, something like this. I'll just wedge it, and then let me put on a rag here because I don't want to damage the case, and then I'll just kind of pry up on it. So let me see if I can get it out without foobarring everything, because if everything's going to be foobarred, obviously that's not really worth even showing. And there it goes. The other one fell on the ground too in the other video. Hey, new seals come in the kit. So case is pretty much empty. This case is filthy, so the only thing we have to do is take out this seal. I'll do that later. But one thing you want to do is put a straight edge here on the worm tracks. Alright, put a straight edge on the worm tracks with a feeler gauge and see if there's any high spots. You can just proactively, if you want, just bypass in the check and simply take a Durablock or a nice block of wood along with some 400 grit to 600 grit sandpaper and just in a unidirectional pass pattern go through over the worm tracks and knock down any potential high spots, because you're trying to reduce the likelihood of cross leaks after this thing goes back in. And you know, when we look at the frictions in the rest of the unit, we'll see if there's, you know, any kind of indications there might have been cross leaks, which would show up in burnt, you know, clutches in whatever circuit, wherever the cross leak might be. All right, let me get this case out of the way, and then we'll go ahead and proceed with the sub-assemblies, tear down the pump, tear down, you know, the drums, the gear train, and I'll go through in more detail all the differences between a first generation and second generation gear train and point out other differences elsewhere, you know, as applicable. All right, got the bench cleaned off. Let's go ahead and look at the gear train. Okay, so we already know that we're going to be needing a front planet. Whether we're going to turn this one or whether we're going to just replace it remains to be seen. That'll depend on how quickly I can get a longer apply pin for that servo, because I'm more than likely going to need it. I mean, this thing has some pretty deep ridges, so it's going to need a lot of turning if I decide to reuse it and turn it. All right, first let's take the center support off. Okay, the rest of this back over here. So we'll look at the center support. All right, so you have Teflon sealing rings on the support. These come in the kits. You can buy them individually, though it's, for whatever reason, getting a little bit harder to find them. But to take the snap ring off and get the piston out is fairly straightforward. So all you're going to do is press down on it, get a pick in behind the snap ring, and then lever it out, and it'll come right out. No big deal. Okay, you have your return spring assembly, and then of course you have your piston. So just check the seals, the surface. If there is an issue, let's just say all of these frictions in the intermediate clutch were burnt up, then we would want to understand why that is. So an inspection of the sealing surfaces here on the two lip seals would hopefully give us an indicator or a direct cause, right? Let's assume they were all rock hard or worn or maybe torn. That would explain things. Check the surface in here, okay? I'm not paying a whole lot of attention to it right now just simply because it's dirty. This will get cleaned up, then I'll check it for real. Same with the inner race portion for your low roller one-way clutch. Okay, and then on the back side you're going to have your upper bearing race. This is going to be for your center support to sun gear thrust. So that goes on just like you see it. Okay, the center supports from 91 to 96. Okay, this portion of the support is the same, but this portion is not. And that's what makes them not interchangeable between the two vintages. The center supports back here are thicker to support the direct feed or plumbing of the return cooler charge into the center support on the 97 and up units. So they have a seal here and they have a return port here. Now it's good practice to enlarge that hole. That'll promote a little bit better throughput flow or a little bit more volumetric flow from the point of entry into the center support and get that fluid quicker to the rear gear train. All right, the bushing itself is different between the two generations, so they're not interchangeable. That has certain holes and ports that this one does not have, and vice versa. So you never want to mix and match bushings between first gen and second gen 4L80Es. Okay, the rest of the center support dimensionally is the same other than the things I just mentioned, but it's very obvious you're not going to make the mistake of installing a second gen support into a first gen case, you know, or vice versa. It's just, I mean, you'd have to be completely oblivious or just simply not aware. And if you're simply not aware, then you know, you could argue you probably shouldn't be working on the unit. But anyway, that's the story with the center support in terms of first gen and second gen differences. The apply piston, see, casting number is 1657. Hang on a minute, let me go get the other apply piston out of the later 4L80. Okay, so here's a late model 4L80E piston from a second gen. It's 2553. This piston is a little different. See if we can see what that difference is. It's not readily apparent, but it is different. And these all take cushion plates, or, you know, wavy plates with legs to secure them or anchor them to the piston. In the 97 and ups, this one did not have that. All right, this may be the same piston as the ones that were installed in the very late TH400s. I know that the piston that was installed in those units carried forward, I believe, to 1995. So I'm almost positive this is the same piston, but I'll annotate for sure just so you know. Get this in here. All right, we'll get this out of the way. All right, next is going to be our front planetary carrier assembly, and we see we have the rest of the bearings coming out. So here is that center support to sun gear thrust. This is the whole assembly, and this is how it goes. So this portion here would be going into the center support, and then you have your bearing. Okay, you just want to check the bearings. Most of the time these are fine to reuse. And then you have your rear race. Alright, here's your thrust washer. This thrust washer goes on the back of the center support and sits right there. So that allows the front planet to thrust against the support body. And then here is the aforementioned 4-tab washer that actually goes on the rear planet. So you have the two planets thrusting against each other using that washer as the intermediary. Okay. Low roller one-way clutch is always replaced. All right, we'll get that out. You know, it's common for the rollers to come out. So some of these will have legs, some will not. The ones that don't, they will feature a support down here or a riser so that that can rest upon it. So you want to make sure that that roller is, you know, at the appropriate height so that it rides upon the race there on the support. Alright, like I said, I don't know exactly what I'm going to do with this thing yet, so for now I'm just going to put it aside and figure it out later. Alright, let's look at the sun gear. Alright, so the sun gear between first and second generation are completely different. Alright, so you have your lube hole here. This is the sun gear shaft. And then you have your sun gear. Now this is interesting because this almost looks like a later model sun gear shaft. But at least it's tanned in color. So let me go get a late model sun gear shaft and I can show you. So here's a late model shaft. This came out of that other 4L80 that I just coincidentally happen to have at the same time I have this one. And as you can see, the shafts are very similar, but they're not quite identical. And the later model shaft has a little ID groove here cast into the splines on the lower portion, where this one does not. Okay, let's look at the sun gears. So again, late model on the left, early model on the right. Notice the cutouts for lubrication on the late model. All right, you see the difference? And then you have the ID groove here on the late model. No ID grooves on the early model. Okay, so when you put this back in, you want to make absolutely sure that this lube hole and this lube hole align. So this goes in on the side where the splines go all the way to the top, where they sit flush with the top of the sun gear. And then on the rear, you'll notice the beveled splines here. They must face rearward because this sun gear is not perfectly symmetrical. The surface area here and the surface area there, relative to the placement with the two planets, is not exactly the same. So that's one tooth off. All right, that's what it looks like when it's perfectly aligned. And it's typical practice to just shine a flashlight up in there, and you can tell immediately if you're out or not. All right, some models have a little oil slinger here, okay, or a damper. Some do not. So if yours has one, yeah, just go ahead and put it back in. Okay. All right, so let's go ahead and disassemble the back half. So you'll have a snap ring holding everything in place. This snap ring can be tough. So I was trying to fight with it using that pick that you see on the bench in the other teardown video, and that was a bad idea. All right. So here's your output shaft, and you have your bearing. And then you're going to have your ring gear, and all you're going to do is just come through like this, push it rearward, and then you have your sun gear to ring gear thrust bearing assembly there. Okay, all three of these bearings are Torrington style bearings. You may refer to them as axial bearings, but they're technically Torrington bearings, are just not all captured. That's the only difference. Okay, I'm going to go through the points of inspection of the rear planet. I'll refer to the front planet too. The only reason I didn't do it with that one is just simply because I'm probably going to replace that. I don't think I'm going to turn it now that I'm thinking about it a little bit more. But here's that reluctor gear that the rear speed sensor reads, picks up on, and sends that in the form of voltage to the PCM. Okay, I have a video that'll show you how to test for your speed sensor to see if it's no good. You could check that out. But on the 91 through 93 model year units, this reluctor gear was pressed on to this planet for the 4x4 units because they had the speed sensor there. In the 94 and up, the 4x4 units did not have this, so this would be missing, and you would just have the rest of the assembly. Now you can take this off or put it on if you're going between 2 and 4-wheel drive. If you're trying to convert, you'll need to do that for anything 94 and up. If you're trying to take a 4x4 unit and convert it to a 2-wheel drive unit, you're going to have to, in addition to the other things, you're going to have to put a reluctor gear onto the planet, or just simply swap a whole planetary carrier from a 2-wheel drive 4L80. All right, so you're going to check in here first. I always like to see if there's any kind of signs of the pinions of being loose or any bluing, any signs of heat. Okay, then you check your teeth, make sure that the teeth here on the ring gear for the reaction carrier, the planetary gear set in front, make sure these teeth are in good shape, no signs of chipping or damage. Check the reluctor gear itself as well as the lugs here on the parking gear. You want to make sure that there's nothing amiss there. And then you're going to just do your usual checks with your pinion gears. So vertical, you want to assess each one for vertical play. All right, by feel, after you've done these for a while, you'll know what's good and what's not, what may need to have, be going through. These feel fine to me. And then you want to check for side play. So you just wiggle the wiggle the pinion from side to side. Make sure that the gear does not move. If it does, then you're either going to replace this, replace the whole thing, or you can have it going through and new needle bearings installed. It's up to you how you want to handle it ultimately. All right, output ring gear and intermediate shaft. You have your assembly for your bearing. Okay, in the 97 and up units, these bearings are a little bit different, and they got cutouts for the lubes, so you never want to install a first generation bearing set into a second generation 4L80. You technically can go backwards. It's not going to hurt anything, but you don't want to ever go trying to go forwards with the old stuff, putting it into the new stuff. Okay, so no first generation bearings in a second generation 4L80, at least not this bearing here. The 99 and up units had something else addition in this location. So underneath that bearing assembly, there was a 41 thousandths shim installed here. Okay, that shim and spacer has to go back in, because if you're working on a 99 and up unit, what they did is they changed the height of the individual pinion gears in both of these planets. So that necessitated changes in the housing, in the structure of the housing, making the structure a little thinner so as to accommodate the additional height of the gears. GM must have done all the design and testing and engineering, and to confirm that taking meat off of the housing itself wasn't going to compromise the structural integrity or make the planet significantly weaker, if weaker at all. They must have concluded that it doesn't, and I agree with that, I guess. So anyway, what this shim does is it recenters the sun gear so that it meshes perfectly with both of the planets. So if you don't put that back in there, then you're going to have a problem with the sun gear and the planets coming out of mesh. And that's another reason why I don't like this bench. Stuff likes to roll around on it because it's not flat. It's got some contouring in the surface, and that contouring creates a problem sometimes. Okay, intermediate shaft. Okay, as you notice, the shaft is bored through the center from one end to the other. The late model shafts, it's not bored through. Okay, again, completely different lube circuitry. This is a lube channel, and then you have distribution here. You have lube ports. So again, another reason why you never want to interchange. So check those splines, make sure they're in good shape, make sure there's no issues with them. I eyeballed it. In fact, here, I'll bring it back again. So you want to make sure these splines are good, especially here around the snap ring groove. Make sure the journals are not severely damaged in any kind of way. Most of these are a little bit out of round, so you'll have issues with new bushings in the sun gear shaft. So just know that you may need to clearance those bushings. Yeah, if you don't clearance the bushings, then you might have aggressive bore or wear in the new bushings, and that of course will ruin your day, because then you'll have all kind of lubrication failures in the rear of the gear train. Alright, here is the output shaft bearing to ring gear. So here is the other race. As you can see, it's a kind of a top hat design just like the others, and you see its orientation. And get it off of there, and then the bearing just goes together like this. No issues with these bearings. Alright, teeth, female splines on the ring gear, journal surface, bearing surface, whole structure. Make sure there's nothing wrong with it. Pretty simple. Your output shaft, okay? Same kind of checks. This bushing will be replaced. Okay, so here's the late model sun gear shaft, or intermediate shaft rather, excuse me. As you can see, it is solid through and through. Okay, there's no oil distribution holes drilled into it. And then here we have our late model output shaft. As you can see, a lack of oil distribution holes. So here are the lube distribution holes for the early style output shaft. And then of course you can obviously see the design differences in terms of the splines. This one took a slip yoke, this one did not. Okay, that is the gear train. So like I said, I'll do a more in-depth video showing you all the differences between all these parts and kind of put them all next to each other so that you can compare and contrast. There's important and key differences between the 97 and 98 gear trains and the 99 and up that you need to know about as well. So none of that is, you know, going to be featured here. It's outside the scope. But just to let you know or make you aware, that video is coming. So if you want to learn more about gear trains, then look out for it. All right. Let me get some of these snap rings out of the way. So just another quick look-see at the intermediate steel plates. Okay, as you can see, the wear pattern, you can recognize you know, the different surface markings or, you know, patterns on the apply piston. There was no cushion plate on that steel. Okay, no signs of slippage at all on these steels. They are perfectly fine to reuse. Same with the backing plate or the pressure plate, if you will. All right, get more snap rings. All right, let's take a look at drums and then we'll finish up with the pump. So this is going to be the direct drum. Reposition the camera a little bit. Okay, direct drum is a bit different from early and late in terms of like everything that's in here. So these have an aluminum apply piston, whereas the late models use bonded pistons, 97 and up. I'm going to pause real quick because this trash truck's going to come through. You're not going to be able to hear much of anything, so I'll come back once it's gone. Alright, trash truck has moved off, so let's go ahead and continue. So we'll empty the drum of frictions and steels. Alright, so as you can see, there's a cushion plate, or wave plate, and then you have your aluminum piston. Okay, so here is the pack. 5 frictions, 5 flat steels, plus your wave. Alright, some folks will say that these like to break and crack on you. There's different cushion plates that are available that you can swap in, but you know, this one looks like it's in okay shape. So as you can see, the dish, alright, the dish was facing upward. Alright, so these clutches are a little bit stressed looking. Okay, the steels look okay. When it comes to building these, I always put new steels in the direct. I never reuse the steels. If the rest of the steels look okay, I will reuse them, but as you can see, there's some slip marks. Okay, it's just normal wear and tear. This is nothing unusual. You know, signs of heat damage on the frictions. Okay, nothing unusual. This is normal wear for a transmission that I believe has 150,000+ miles on it. It's never been gone through to my or the customer's knowledge. Shift kit was put in it, but beyond that, yeah, it's been largely untouched. So definitely some signs of stress. A wafer pad on an angle grinder, you can kind of prep the surface a little bit and remove some of this glazing and slip marks. That's no big deal to do. So, again, it's nothing unusual here based on what I'm seeing so far anyway. You know, nothing that leads me to believe there's any kind of line pressure issues or sealing integrity issues in this clutch pack anyway, or the intermediate. Okay, here is your snap ring. Notice, ideally you want, I mean, they installed them from the factory like this, where one of the ends is right on a locking tab. I like to put them in between, but as long as you're engaged on all 4 sides of the tab when you go back with it, that's fine. No biggie. Alright, this one has a spiral lock ring. So let's go ahead and take that out because we need to replace the intermediate one-way clutch assembly in these things. They never get reused. Always replace your clutch assemblies. So there's 2 locking tabs on this spiral lock ring. It's nice that he has this because, like I said, some of them, the earlier units, I believe they were all traditional snap rings. Okay, so we have a what I believe is a 16 element roller assembly or sprag assembly. So with like this, I'm just going to put a 34 element assembly in here. I'm not going to put a 16 element. All right, and then your race, you just want to check this out, make sure it's not damaged, scored up, or blued, signs of overheating, anything like that. If your transmission suffers what we call a rollover, in other words, the one-way clutch rolls over and such that it freewheels in both directions, then you're going to have an issue with this race. No matter what it looks like, you cannot reuse it. So let me put it back together. Sprag rotation is going to be freewheeling clockwise, lock counterclockwise. So let me just real quick put it back on. And then this side faces up, faces you. Alright, I don't know if that's going to work out the way I want it to. I should have shown that earlier, but all GM intermediate sprags and TH400s, 4L80Es, there we go. They rotate like this and they lock counterclockwise. Rotate clockwise, lock counterclockwise. Alright, so what I was saying is if you suffer a rollover, you're going to have to replace the whole drum. You can't reuse it. So that's how it goes. Alright. So we will put a 34 element assembly in there. I'm going to check the race surface itself. Make sure, again, there's nothing obvious. Check in here where the sealing rings go for the center support. You want to make sure there's no grooves that the sealing rings may have cut into the inner diameter of the drum here. If you can feel, if your fingernail is getting caught up when you run it over the sealing ring impressions, then you need to replace the drum. All right, and obviously check the band surface and check the, for cracks or anything. Every once in a great while, I'll actually see hairline fractures right here on the drum. So again, I don't really look at these with any degree of criticality until they're clean, but every once in a great while, I will see cracks right here where the lug meets, the rest of the surface, right? Where you have the male lug and the female lug or female cavity. There's cracks there from time to time. I've seen it. So if you see it, then again, you need to replace the drum. So let me get this snap ring out and then we'll look at the piston. All right, return spring assembly. To my knowledge, these are the same, no different. If you're running a real high horsepower, high performance application, I recommend installing high rate return springs in this assembly. It's kind of a pain, but it's necessary to prevent centrifugal apply. If you're going to be racing and you're putting out like 600-700 horse in a very high stall converter, it's going to be winding up, say, 7,000 RPMs or something crazy like that, then you're going to want to drill an additional bleed hole in the drum itself, just underneath the sealing surface so that you can vent and exhaust that excess fluid that's going to pool underneath the piston. Otherwise, you may have either what's called centrifugal drag or even centrifugal apply. And if you have centrifugal apply, what's going to happen is you're going to shift wide open throttle from first gear to second gear, and then all of a sudden you're going to find yourself shifting into third gear, okay, where it'll slip in third gear, then it'll grab. And that's applying out of schedule. It's true of TH350s, TH400s, 4L80Es, and anything else where you have, a clutch-to-clutch transition, meaning there's no shifting bands like a 4L60 or a 700R4. I mean, they have their own problems that you need to look out for, but when it comes to these transmissions, that's something you want to be mindful of. So here's our piston, okay? Notice here we have two cavities. We have a surface area here, and then we have the cavity here. I shouldn't say cavities, just two distinct apply surface areas. So when you're dual feeding these transmissions internally, what you're going to do is you're going to take this center seal, remove it, and leave it off. Okay? You're going to install the lip seals onto the piston. Then what you're going to do is you're going to plug the high reverse feed passage in the case. That's if you're looking at the center support. Here's the center support. Okay, the location in the case corresponding to this feed passage here, you're going to plug that with a 3/8 of an inch cup plug, and I always use red Loctite. And then from there, you'll want to drill out the 2-3 feed a little bit more than you otherwise would, because you're basically creating a quasi-accumulator for the 2-3 in addition to the accumulator that already exists on the valve body assembly. So you don't want any kind of delayed engagements or weird shifting patterns from 2 to 3, or reverse for that matter. So you want to make sure you drill that out. But that's a little bit beyond the scope of this video. I have 480E high performance, and I kind of go into detail about doing that. All right, so let's look at this seal. This seal feels kind of hard to me. I mean, you notice it was kind of a, I don't know, a little bit of a challenge getting it out. It didn't want to come out. It's still supple, but there are portions of it that are starting to harden. And that could partially explain the pattern of wear that we're seeing here on the frictions. Okay, the seals on the piston, they feel fine to me. But in direct, only this cavity is used. This area of the piston is not used. It's partitioned via this seal. So if you have a little bit of leakage into this area of the piston, not enough to fully apply it in third, it's just leaking because this inner lip seal is worn, that could explain some of the stress patterns we see on the frictions. Okay, so I think I've said everything I want to say about the direct drum. Check the band surface. If you want to check it for warpage, you can get a straight edge, shine your flashlight. I show that in several videos. I'm not going to do it here, but you kind of get the idea. And the other thing I'll mention is, if you're new to a transmission, keep all the lip seals on. If you're not sure, maybe you might get confused as to what lip seals go where. If there's lip seals that are very, very similar but not quite identical, meaning you can't just inadvertently put them in the wrong spot and have it be okay. Just keep them on the pistons or wherever they are so that you don't run into that issue. You're not confused. All right, we have our forward drum. So here is our thrust washer. Okay. All right, this is going to be the forward clutch hub. So with these hubs, they're pretty resilient to damage. I mean, for stock and mild builds, you really don't need to do anything like replacing them with billet or heavy-duty clutch hubs. You can if you want. For a relatively low-cost upgrade, assuming it's in your budget, though, if you can swing it, the Sonex forward clutch hub is rollerized, and it's a heavy-duty. I think it's billet, but it's advertised as a heavy-duty alternative to the factory hub, and it does come with roller bearings. So anytime you can replace a static thrust surface that uses traditional thrust washers like either Babbitt or plastic with roller Torrington bearings, then all things equal, you want to do it. But again, you'll have to make the decision on whether or not that's within your budget. So with this hub, like I said, they're fairly resilient. You just check, make sure it's not cracking, because in high horsepower, high RPM, a lot of torque going in, this is going to be the first failure point in most cases. So you're doing something real high performance, a billet steel hub is pretty much mandatory, especially if you're going to be above 500 horsepower. And it's just a general guideline, of course. Everything is a judgment call when it comes to stuff like that. Okay, so we have the same cushion plate. Okay, if you have concerns about these cushion plates, just replace them with a different type of wave plate. Like I said, these have been known to break. So, all right, the steels on the forward clutch are thinner than those for the direct clutch, the flat steels. The frictions are the same thickness, but the steels are thinner. So if you're having some issues with obtaining clearance, it's too tight in the direct, you can swap a forward clutch pack steel plate in there, and that should usually get you where you need to be. Okay, direct, I want to say 60 thou is kind of a good benchmark or standard. That's where you want to be at, or I guess the best word to say is target. And forwards can be down to like 30 because they're not really working. Generally speaking, factory frictions and steels, if you're using everything that's in spec, you won't have any issues with clearance. You're going to check them, of course, but you're not going to have any issues with getting your clearance. If you're using performance frictions, or you're doing, you know, some different things, deleting the wave plates and all this other kind of stuff, then at that point it's going to take a little bit more iterative, you know, guess and check or trial and error to get your clearances to where you want them. All right, the forward clutch looks good. No signs of, you know, pressure issues in that apply circuit. I mean, the steels look in perfect shape. A little bit of wear to the frictions, but, you know, again, this transmission technically worked. It was just simply bang shifting. All right, let me go get the snap ring out, and we'll look at the forward piston. Alright, these two return spring assemblies, forward and direct, are the same. I haven't seen any differences in either of them. Okay, here's the piston. So it says forward right there, so there's no mistaking it. Let me pull the direct piston back out of there, and we can do a quick comparison so that you have a frame of reference. And we've got that trash truck coming around again. Okay, so here they are from the front. Alright, you notice it's wider here on the direct. The direct is in my left hand, the forward piston is in my right. And then we'll flip them around once again. And forward is marked, direct is not, but you'll notice the casting numbers are different. Put all that back. Alright, and then you have your forward drum seal here. Okay, this lip seal feels a lot better than the one in the direct clutch, and that's normal. The direct clutch is going to see more heat, it's going to see more stress, so it's going to wear faster. It's going to have a shorter lifespan. Okay, you can leave this out if you want. The reason that seal's in there is to kind of help soften the engagement into forward gear. Alright, check your ring gear for your overdrive planet. Make sure there's no cracks, make sure the splines are in good shape. You don't want to see any fracturing, you don't want to see any signs of damage. If you do, you're replacing the forward drum. I wanted to wait for that trash truck to go by again. Alright, let me separate our frictions and steels here, and then we'll take a closer look at the drum itself, because as I'm sure you know, or maybe you don't, but if you do, it'll be repeat. If you don't, then it'll be, I guess, new. But these drums have a bad problem with wear in the sealing ring groove area on the inboard side of the input shaft. So here's the bearing. That's going to thrust against the overdrive planet, you know, the base plate of the planet. Okay, it goes just like this. This one's fine. And then this is where I'm talking about, right in here, deep in there. In fact, let me flip it around, it'll be easier to see. What we want to look for here is grooves cut into the inner diameter by the sealing ring. So as the input shaft is you know, spinning round and round, it will cut grooves into this drum. And those grooves, if it progresses you know, bad enough, then you'll start to have delayed engagements in first gear. So, you know, garage engagement into drive will be very delayed, and you may start to slip once it gets progressively worse, or to the point where you're just having, you know, an immense amount of blow by. Roughly half the apply fluid, once that starts leaking past the sealing rings, maybe even a third, and I'm just guessing here, this is not anything I read, I'm just guessing, you'll start to see out and out slippage, and then, you know, short order will burn up. So look in here. For high performance, you don't want to use a stock bushing here, stock replacement bushing. You want to actually go with a wide bushing, because the wide bushing will provide a little bit more stability and, you know, increase the surface contact area between it and the journal for the overdrive planet. Omega Machine makes wider bushings, and you can just purchase them individually and press them in here. All right. Check your bleeder balls for both forward and direct, because if these balls are not functioning, then you'll have fluid pulling in behind that apply piston. And in the case of forward, if it's clogged up real bad, enough fluid will get in there and you'll start to move forward in neutral and park. I mean, it'll want to move. You'll have a bind up in reverse too. So you want to make sure that these little bleeder ball capsules are functioning in both drums. All right. I don't see them bad too often. In fact, I don't think I recall ever seeing one bad. Never had one come in where, where that particular bleeder ball capsule is no good. But you always want to check just to be sure, because you know how Murphy's Law is. Alright, let's get all this stuff kind of out of the way. Alright, let's do the overdrive section now. Alright, so here are the sealing rings in question. And then here is the surface for that bearing. The bearing thrusts here on the base plate of the overdrive planet. Sprag rotation on the overdrive planet is freewheeling counterclockwise and locks clockwise. Okay, so freewheel counterclockwise and lock clockwise. Alright, I went over this a little bit in the teardown video for the later 480E, but general rule of thumb when it comes to sprag rotation, if you're not sure for whatever reason, okay, the sprag rotation will have a relationship with the direction that the clutch basket is facing. So in GM transmissions, when it comes to the intermediate clutch and intermediate sprag that's on the direct clutch, the clutch basket faces forward. So when the clutch basket faces forward, your sprag rotation is going to be such that it freewheels clockwise and then locks counterclockwise. If the clutch basket is facing to the rear of the case, like what we have here, the sprag rotation or roller clutch rotation is going to be freewheeling counterclockwise and locking clockwise. Alright, so it's a general rule of thumb. I'm sure there's exceptions, but from everything I've seen, that rule generally applies. The overdrive roller clutch design changed in 2001. They went to a smaller design that used thinner rollers. I'm not really sure what the rationale was. I think GM had some concerns about the larger rollers deflecting under higher RPMs, and so they decided to deal with that by just making the rollers smaller, and that resulted in a what we call a service pack level change. So in other words, the rollers changed, so consequently the race diameter changed. The cams on the planet, they changed as well, and none of that stuff is interchangeable individually. It's all interchangeable as an assembly, just not individually. Alright, that was sloppy. Alright, so input shaft. Just check your journal surfaces and your splines. You want to eyeball the splines that go into the torque converter. If these strip, then you're not going to have any movement in anything. Okay, and then you can diagnostically check your sealing rings. Sealing rings either worn, flattened, or cut would indicate a problem, or at least explain a problem or a drivability symptom that may have been reported by the customer to you, or if it's your transmission, you'll understand, why whatever was going on was going on. All right. Okay. As far as the interchangeability between the shafts, I'll have to double check and I'll annotate the video. I don't know if they're directly interchangeable. I think they are, but I don't want to say for sure, so just look for the annotation and that'll tell you. Alright, so as we know, sprag rotation is, or I should say roller clutch rotation is counterclockwise, so that's how you're going to take out your planet to expose the roller assembly. Okay, these are always replaced, they're never reused. When it's making that screeching sound, that tells you it's healthy, it's in good shape. It's technically serviceable, but on all overhauls, that's a soft part. So you always want to replace that because you want to reset the aging clock to 0 for those things, as well as all your applied elements and all the other consumable stuff. All right, so here is the planetary carrier. You have a captured bearing. You want to check it. Okay. This planet can be disassembled at the end user level. You don't need to do anything special or have special tools. So this snap ring comes out and you can replace these pinions. You could put new washers if you need to. If the washers are such that they're worn and you had a lot of vertical travel, you'll want to do that. Okay. So I'm just doing all the normal checks that you would do, side to side, vertically, up and down. Everything looks good to me so far. Check your lugs. All right, if there's like wear or grooves cut into the lugs, then it'll grab on the frictions and they may or may not apply, or you'll see delayed engagements into for your coast clutch. Okay, engine braking may or may not be as effective, or may not come off, so it'll drag. Check your race. Okay, the race should be nice and smooth. There should not be any burn marks or any signs that it was overheating. Same with all of the pinion locations. So you can enlarge the lube to the sprag, or I'm sorry, he keeps calling it a sprag, it's a roller clutch. You can enlarge the lube passage to the roller clutch in the pump for anything high performance. That's what I typically do. For stock, it's not super critical. All right, let's take a look at the coast clutches themselves. So you're going to have a little up stamped into the backing plate for your coast clutch. Okay, Borg Warner. These look in good shape. All right, second generation 4L80Es. The steels were all drilled, if you will. So allow for more efficient passage of fluid through the steels to reduce drag and to promote better thermal characteristics. So you can install late model steels into an early model unit. That's fine. This applies to these and the Overdrive clutch pack. All right, these steels look good to me. All right, here's the drum itself. So you have your snap ring. You're going to need a pretty robust foot press or a shop press to get this thing off and then back on. And then of course you have your bonded pistons. So I'm going to go to the press. I use that adjustable 3-legged spring compressor in combination with the shop press to take off and then put back on. So if you have that, then that's what you want to use. All right, I'll be right back. All right, so return spring assembly. Just like any return spring assembly, you just want to make sure none of the springs are broken or missing or whatever. Kind of obvious stuff. And then here is your piston. Okay, this piston, the lips on the sealing surfaces feel somewhat hardened to me here. Hey, this truck is used to tow stuff occasionally. I think he has a flatbed that he puts like recreational vehicles on there, like quads or ATVs or whatever. Nothing real serious, and I think maybe he also uses it for some light landscaping work. But if this piston is real hard, you're going to obviously burn up your coast clutches, and your ability to maintain engine braking will be compromised. All right, let me get this stuff out of the way. Stack stuff on top. All right, next we will look at the overdrive assembly. So this is going to be your overdrive clutch. So this is different than later model units. The later model 99 and up, they changed the case, the apply plate, and the housing so that it accommodated a kind of large flange on the overdrive apply plate, and that kind of mated with a stabilization pin that was installed into those cases, and that allowed for greater stability and I guess equal symmetrical apply of this clutch. So I guess the problem was that because it's so big, maybe one side would deflect a little bit or apply faster than the other side, kind of like this. I mean, I'm exaggerating this big time, but just to kind of illustrate what may have been happening. So notice here you have the little lug here for the teeth. When you go back with it, that's where it goes, or how it goes. Hey, this snap ring is also very large, so it can be kind of tough to get out. All right, overdrive frictions and steels. So you have your flat steel. There is no waved or cushion plate in here. So These frictions look good to me. The steels look good. No obvious signs of heat or slippage or anything like that. I mean, everything looks like they, have plenty of life left in them. So this is a good size clutch. The Ford counterpart 4R100s, E4ODs are roughly the size, maybe a little bigger. But all in all, 4L80E doesn't give anything up to those transmissions. They're all good transmissions, by the way. The 4L80E, though, you require a lot less updating and correcting compared to the 4R100s. Alright, so you have your piston and your piston housing, and it's all held together by the snap ring. The snap ring is fairly easy to remove yourself without the aid of any kind of press or anything special. So, and the same goes for installation. So all you're going to do is you're going to compress with your hand, this part of where the snap ring end is, and then just simply go all the way around. And then continue to compress so that you get the locking bosses collapsed below the snap ring as you kind of withdraw it. And then when you go to put this thing back together, you're just going to do the reverse process, and I mean that's it. Alright, there is a special set of tools made by Kent Moore to very efficiently mesh these two parts here, the piston and the piston housing. Alright, like I said, if you're new to 4L80s, you want to leave the lip seals in place. I mean, you could check these seals. There's nothing to indicate that they're hardened or worn out or whatever. They feel fine to me. The sealing surfaces all the way around feel good. Okay, no issues. The return spring assembly itself looks fine. And then, of course, your snap ring. And so we'll get all this stuff out of the way. Alright, we'll have a look at the two bands again real quick. So the braking band for manual second does have a little bit of heat. A little pattern here showing there was some overheating or some contact where there was some heat introduced to the band. Not a big deal. I mean, this band gets replaced. And then the low reverse band actually looks pretty good, pretty decent, especially in the area of the apply. This is where it grabs. That's what you want to check, but we replace those no matter what. Alright, now it's time to take the pump apart. Okay, so the pump is heavy, so I want to make sure that I put it on something stable. $13mm on the pump half bolts, and then you just want to make note. So with these pumps, neither the stator support or the body are interchangeable with anything after 1996. Okay, you can interchange anything between 91 and 96, stator support, pump body, doesn't matter, but you cannot prospectively install either the stator pump cover or the pump body into a 97 and up transmission. Alright, shimmy the pump, just so you don't take the pump gears out with the stator pump cover. Alright, a whole lot of fluid here. Let me kind of drain some of it. All right, so let me reposition the camera a little bit. We can get a little bit better view of what's going on. All right, first we'll take a look at the pump body. I'm gonna get some of this fluid off of here so we can see the gears. You can reuse these pump gears if everything's in good shape, if the clearances check out, if you know, there's no reason to suspect that they're bad. So we'll start with the drive gear. And the other thing you could do, and I'll do this sometimes, is you take a little brake cleaner, just, you know, spray a little brake cleaner to dry off the surface. And then you can mark, you know, the faces of each gear to kind of create an index so that you know how they should go back in, you know, if you want to. I don't know how critical this is, to be honest. It's just something I've always done if I was going to, you know, if there was a possibility I would reuse the gears. So anyway, here's the drive gear. You want to check this area in here where it engages a torque converter. Sometimes there will be a lip that will form here, and so the converter will be tough coming out, and then you will not be able to get the converter back in, or a new converter on. That happened to me once, and you know, I had to come back and I had to deal with it because I just missed it. But this was very, very early in my you know, doing 4L80s. But you want to check that, because if you can't get the converter back in, then obviously nothing's going to happen with respect to the transmission. Okay, driven gear. All right, and what I say about the driven gear here, as far as the teeth, it'll apply to the drive gear. Check these teeth. Make sure there's no signs of chipping or cracking, fracturing, or anything like that. Every once in a great while, I'll see the driven gear broken in half. You know, that's usually a sign of either abuse, excessive RPM, and or you know, low on fluid. All right, check this surface here. Make sure that there's no scoring, no grooves cut in it, no signs of heat damage. This, both drive and driven gear, superficially anyway, or at a glance, look very good to me. So once they're cleaned off, if I don't see anything that, you know, leads me to believe I need to replace them, then I'm just going to reuse them. Factory gears are, you know, good to go for pretty much forever, as long as they're in good shape to begin with. Okay, for your pump body, all right, you want to inspect the working surfaces. Okay, you want to inspect the deck surfaces. You're going to check your clearance once this thing's all cleaned up. But the main focus of your inspection needs to be the crescent, because if there's wear in the crescent, it doesn't matter what the rest of it looks like. Wear in the crescent will result in volume flow issues. So in other words, you won't have enough fluid volume and consequently fluid pressure being created by the pump to properly keep all of your clutch packs firmly clamped when they're applied. And where that usually shows up is in third and or fourth gear. You know, you start to have flare shifting, especially at higher throttle angles, or you just start straight up slipping, and when you go to do a line pressure test, your line pressures are below spec for both at idle and at stall. So you want to really carefully look at this, and I'm not going to pay too much attention to it right now. This has to be cleaned off, and then I'll study it. All right, you can check the front seal, just again for diagnostic purposes. Obviously, you've never used this seal, but if you had a leak at the converter, more than likely it's because of this seal. Bushing will get replaced. There's a drain back location here, so you'll want to, this is the drain back location on the other side of it. So you want to drill this out 1/4 of an inch. And especially on the earlier units like this, they occasionally had issues with too much fluid pulling in behind the seal and blowing out the seal because drain back wasn't efficient enough. It's just a good preventative measure. And, you know, it's not to say that that's guaranteed to be a problem, but at the same token, you can address it. It only takes, like, you know, a minute or two to drill that out. So a 1/4 inch bit, just use a, you know, relatively new drill bit. I buy them in packs of like 8 off Amazon, and, you know, because I use them a lot. All right, let's see, what else? We talked about the interchangeability. We talked about points of inspection. We know we can use this pump body on any year 91, 96, but we know we can't use it on anything beyond that. And same with the pump cover stator support. Okay. All right, here's your casting number. This is how you can refer to the pump. I'll do a separate video that compares the early and late pumps, because there's a period between 1997 and 2007 where the two different pumps were manufactured, because there were two different patterns at the pump to case surface when it came to the when it came to all the holes. Particularly for the cooler supply and return line, as they were transitioning away from the traditional lube to the center lube. So I'll do a video on that, but at least you're aware of it. And I think Transgo has some instructions on their website, which I'll link into the description, and they kind of spell it all out for you. So anyway, let me get this out of the way. All right, so here is the pump cover / stator assembly. So as I mentioned, we have our sealing rings, old school one-piece Teflon, needs a special Kentmore tool to resize them. However, don't despair if you don't have such a tool, you don't need it. I'll do a separate video on this because I mentioned it several times now recently in videos. But on Amazon you can buy these sheets of rubber, and I think they're 1/16 of an inch thick by 8 by 11. And you can use that in combination with hose clamps of an appropriate size and make yourself resizing tools for any one-piece Teflon sealing ring for any transmission. I think the total cost is literally 15 bucks between the hose clamps and these sheets of rubber I'm talking about. So do not buy any special tools for ring resizing. You don't need them. I'll do a separate video, but if you go on Amazon and you search rubber sheets or something like that, and I'll put what you need in the video just so you don't have to search. But if you're so inclined, that's where you can find them, and they're dirt cheap and they're very, very effective. If you've watched my 204R assembly video on one of the, I think it's part 3 where I do the overdrive section, I show that whole deal being used. All right, I'm not going to mess with the sealing rings for now, but I'm going to take out the boost valve, the lockup valve, and the rest of the valves so you can kind of see what they look like. I did this on the later model 480E teardown as well. So let me get some of that fluid out of the way. We'll put a paper towel and then we'll go through and put the valve trains out on the bench so you can see. Let me reposition the camera a little bit too. Okay, grab my items that I'm going to need. First things first, I'm going to remove the boost and pressure regulator valve so you can see what that lineup looks like. So again, just use your snap ring pliers. I gotta switch these around. Alright, so first go like this. Just make sure that the boost valve is able to move and return to the snap ring under under spring tension. And I think I literally got caught on my glove. How about that? Alright, just keep doing this. Eventually it'll get to the point where you can wedge it out. So I'm just prying in behind the radius here on the pressure regulator valve, and that'll allow you to get the boost valve out. Okay, so you have your little washer or spacer. This is for the main spring for the pressure regulator valve. This is the boost valve spring, a little buffer spring or whatever. So your sleeve, your valve, your little spring, and then the washer or the spacer. I don't know if you're going to be able to see this or not on the camera, but there is a subtle difference between this side and this side. This side is what faces the pressure regulator valve spring. spring and PR valve. Okay, these springs are good for about 175 psi max working pressure. So if you need more than that, then you're going to want to upgrade to a beefier spring. The Sonex 4L80 LB1 kit comes with a spring. I think it gives you another 10% of pressure. I install that particular kit on all my 4L80Es, and the equivalent for the TH400s, or pretty much any transmission I'm building, it's going to get a Sonex boost valve kit. And in most cases, their springs increase pressure by somewhere between 5 and 10% on average. You can also use an additional shim or spacer to achieve kind of the same thing if you have one laying around, or an appropriately sized cut washer. The TH400s, you can use an additional horseshoe spacer for, again, the same purpose. So on the back side, there's going to be a plug with the roll pin, so we'll remove that. And I'll just put that there. And then we'll just tap out the little plug. Alright, so that's that for the boost and PR valve. So now here's your torque converter clutch control valve, or lockup valve. I want to make sure that I'm still in the shot. One thing about YouTube, and it took me a long time to really get this to the point where it's second nature, is camera angles. I'm still constantly having to check to make sure that whatever it is I'm doing, it's visible, because sometimes you start working away and you're not thinking about where the camera is or what's going on, and next thing you know, you film an entire segment and literally only half of what it is you want to show, or maybe less than half, is actually in the shot. And as a result, whatever it is you're doing, nobody but you can see it, and you don't realize it until it's too late. Alright, so what I'm doing here is there's a roll pin with a plug in the rear. So what I'm doing is just taking this screwdriver and seeing if I can force this ahead. Sometimes they'll come out, but a lot of times they won't. A lot of times this plug is straight up stubborn. Alright, so what we're going to do is we're actually going to take this roll pin out. I need to use the hammer. Take the roll pin out. And then you're going to take the plug out, or the plug's just going to come out. And it's like another little drift punch is falling down. So I take it out, and then the little plug should come out. And what things should be doing and what they are doing are two different things with this pump. Alright, so there's your plug, and there's your spring. And then this is what fell on the floor. This is what I like to use to tap out that front plug so that the valve will come out. Alright, when you're taking these valves out, just kind of get a sense for any drag that might be present. Like this came out nice and smooth once this plug was out of the way. If you get a lot of drag, or when you're going back in with the reassembly it starts dragging, just use bench buddies to polish the bores a little bit. I mentioned this in the other video, I'll say it here too, just because every once in a while I'll get somebody commenting they don't like bench buddies for whatever reason. But bench buddies are a great way to recondition bores. Alright, they're not that expensive. Whatever it takes, or WIT Performance makes them available on their website. You can also buy them off eBay, WIT or from somebody else. But bottom line is that they're very, very useful, and I don't care what anybody says. So, all right, this next valve. Hey, you have a TV limit valve, or a converter limit valve, excuse me, and then an enable valve, and you know, I still don't know which one's which offhand. Of course, I'll annotate the video with a pump diagram so you can see what exactly the orientation is and what goes where, and most importantly, what these valves are called. All right. So this next valve here, okay, you have a cylindrical retainer. The easiest way to get at that is through a very thin blade screwdriver. Just come up in here like so, and then start tapping. All right. And then once it's out to an extent, you can grab up on it. Just go ahead and grab some pliers, and it'll come right out, and you won't damage it. Here's your spring. And this valve is shy. A lot of times it will not want to come out. It doesn't want to expose itself, I guess. Yeah, just like that. Okay, so pump cover is now free of any valving. So at this point, we can put it aside, and we can also wrap up our teardown inspection of this video of this transmission. Okay, we have all the parts here on the bench, case completely empty, and other than the valve body, everything's been disassembled. So this thing's going to get a complete overhaul, which means a cowl kit, complete bushing kit, all new one-way clutch assemblies. We're going to need to replace that front planet. I'm going to be installing a Sonex 4LADE LB1 boost valve, their 1, 2, and 2, 3 shift valve spring kits, the TCC valve that Sonex makes, and then I'm going to probably install an AFL valve from Central Valve Bodies. It's just a drop-in valve. 4LADEs have a kind of a problem with AFL valve wear as they get a lot of miles on them. So it's just good practice. I think it's only 25 bucks shipped. As far as machining, if necessary, we'll have the stator support machine. Same with the pump body, although I don't think that it's going to need it just based on what I'm looking at. It'll get a rear band. Like I said, I always replace those. A new bonded piston for the coast clutch, and a new steel module for the direct clutch. We're also going to rollerize the rear of the case, so that consists of the TH350 pump bearing and shims. We install that as described, and I'll also purchase an extra pump body bushing for the rear of the case. And regardless of what year 4LADE you're working on, or even TH400, that's the bushing to use. When you install it flush, as far as looking at from the rear of the case, it's flush with that bevel, if you will. Enough of it protrudes into the case to allow you to locate that TH350 pump bearing and 1 or 2 shims. So it's like perfect. Alright, as always, thank you so much for watching. I greatly appreciate it. If there's anything else that I'm missing or anything that you would like me to cover in more detail, just let me know in the comments. I'll annotate some of the stuff that I went over where I wasn't sure, and where I couldn't give you more specific information. Apart from that, I may film the reassembly of this. I may not. I don't have what I would refer to as a stock or mild build on the channel for 4LADEs. I have that high performance build, but I mean, that's almost night and day in terms of the parts and the procedures and things you would need to consider compared to something like this. So it might be good if I have time. The customer will let me, because filming takes a lot of time. It adds to a rebuild. I mean, it basically doubles the turnaround time. If the customer's good with it, and he may be, because this is not his primary vehicle, I'll go ahead and film that, and we will put that on the channel as well for folks looking for just a good template for a basic overhaul of one of these transmissions. Because while the high performance is all cool and all, and I mean, you got a lot of whiz-bang parts and gee-whiz procedures, 99.999% of the population is not going to be building a 4L80E to that extent, so it may not be as useful. Anyway, again, thanks for watching. I really appreciate it. Can't tell you how much I'm grateful for your viewership, especially if you lasted this long in the video. So until the next time we meet, take care, enjoy the rest of your day or evening, and we will see you then.